Okay, hello everyone. It's my great pleasure to talk about introduce the company Pocel Inc. Let me first introduce myself. I am Seok Cha. I'm a professor at the Seoul National University, and I am one of the co-founder of the Pocel Inc. And I've been working on the fields of research for more than 20 years. Before we go to some technical details, let's just briefly review some of the fuel cell vehicle market. So as of the end of the last year, I believe there are more than 25,000 fuel cell vehicles operated around the world. And then it was a 95% increase in the last year. And then the year before that, in 2018, there was also like 80% increase, but it looks like it's the number of the fuel stock is accelerating very fast. And then more than half of the fuel cell vehicles are operating in Asia, and then mostly it's passenger car, but there are also some the buses and then medium duty vehicles. And then those buses and the medium duty vehicles are mostly operated in Chinese market. And then, but in contrary, the South Korean market is dominated by the passenger car. There are many the hydrogen technical roadmap, or the roadmap for the hydrogen vehicle has been announced in many different countries like China, Germany, South Korea, Japan, all the like Spain and all EU countries, and also the California. And then most all these countries named are very aggressive, especially deploying the fuel cell vehicles. For example, like in 5 years, about like 5,000 like fuel cell vehicles, or like 200,000 vehicles will be deployed in Japan or in China. And then if you go to like a year 2040, like in Korea announced that it will going to dispatch about 6 million of fuel cell electric vehicles. So all the like the developing countries are very aggressive on the deploying the fuel cell electric vehicles. Fuel cell electric vehicles is very similar to other types of vehicles, but it also has some differences. Here are some typical types of the electric vehicles. One is the hybrid electric vehicle, which uses internal combustion engine and with battery power. Or if you can charge those batteries, we call it a plug-in hybrid electric vehicle. So it's the same as the hybrid electric vehicle, which uses gasoline, and or the internal combustion engine and battery. But if you can charge the batteries, it's called plug-in hybrid electric vehicles. Or if you further reduce the size of engine, which is like very small engine, and then most of the power comes from the battery, then we call it extended range electric vehicle. That means the driving range is extended by charging the battery using the small internal combustion engine in the vehicle. Or there are also the pure battery electric vehicle. So the major power source is coming from the battery. So there's no engine. Or there are also the fuel cell electric vehicle, which has the battery and fuel cell. So fuel cell charges the battery, and then it can drive a long range. Typically, fuel cell electric vehicle shares most of the parts from the battery electric vehicle. So it's a good way of building the fuel cell is using the most of the parts from the battery electric vehicles and add some of the key parts that comprise the fuel cells. So that means fuel cell electric vehicles can use the supply chain of the battery electric vehicles too. Here are some typical fuel cell vehicle specifications for the most the popular fuel cell vehicles, like from the Toyota, Mirai, Hyundai Nexo, or Honda Clarity, or even Mercedes-Benz fuel cells. And then most of these are the four different the vehicles, right, in order. And then typically it can drive like 600 or even 700 kilometers. So it's typical for most of the companies. And then it stores the hydrogen around 700 bar. It's very similar between the different automotive companies. So 700 bar is kind of the standard in most of the fuel cell electric vehicle, especially for the passenger cars. And then also size is almost with small. It's the size of a small SUV. So this is like the most of state of art the fuel cell vehicle specification around the world. Fuel cell electric vehicles, it has some major key parts. First, the fuel cell electric vehicle has the fuel cell stack. So it's the fuel cell, and then if you provide hydrogen, it generates electricity. And then there is so-called MBOP, or mechanical BOP, balance of plant, means that mechanical auxiliary devices that's requires to operate the fuel cells. For example, hydrogen supplier, air supplier, or thermal management system, or the water management system for the fuel cell stack. And there's also some key, another key component called electric balance of plant, or EBOP, which is takes the in charge of the electronic part. For example, inverters, power electronics, or motors. So these parts are mostly shareable with battery electric vehicles, and also the fuel tank. In case of fuel cell electric vehicle, it uses hydrogen as fuel, so it has a hydrogen tank, so which can store the compressed hydrogen. And then the safety is always the issue, so there is a safety control. If you take a look at in more detail about the fuel cell stack, this is like schematic of the fuel cell stack, then it has like some key components. There are some key components, and the one is the bipolar plate, which with the flow field. So this bipolar plate needed to provide hydrogen or air to the fuel cell. So this bipolar plate is key part. And also there is the electrolyte. And the electrolyte is typically made of the membrane type. So there is a membrane. And also that there is a gas diffusion layer with catalyst. So fuel cells uses the platinum catalyst. And then there are carbon components. So it's a gas diffusion layer with catalyst. It's composed of catalyst, platinum catalyst, and carbon materials. In the fuel cell system, there has been many like cost analysis, and then this there's from DOE, and then the key factor is the mass production. Okay, the fuel cell technology is actually mature enough. So if you look at this data, these are the prediction of the price of the fuel cell system, the dollars per the kilowatt of the fuel cell. And then you can see if this different line is a prediction for like 2018 technology, 2020 technology, also 2025 technology. But as the time goes by, the price difference is not that different. But when you increase the number of production, it reduced dramatically. So it's the same for the similar situation for the heavy duty fuel cell systems for trucks and buses. So what the people predict is the mass production is the key component to reduce the price of the fuel cell system. Now let's take a look at the component price of the fuel cell systems. This is also from the prediction from the DOE. And then in case of the low volume case, we have seen some key components of the fuel cell stack. Then you can see it has like the bipolar plate or membrane, or the catalyst, or the gas diffusion layer, which is made of the carbon fibers, and then there are some the gasket materials, or the balance of stack that which required to operate the stack, some key components like end plate and things like that. In case of low volume production case, you can see the challenges are the membrane, membrane, or the gas diffusion layer, or catalyst comprise the most of the price of the fuel cell stack. But if in case of the high volume, the situation changes, and you can see the catalyst, catalyst, and the bipolar plate actually account for the most of the price. So when we go for the mass production, the key question the challenges that we will have is how to reduce the price of the catalyst and bipolar plate. But usually the catalyst, we use the platinum, the particles. So basically it's very difficult to reduce the price because the raw material itself is expensive, or we have to find another way to substitute platinum with some other cheaper metals, which is a very, very challenging task. So this is from the analysis from the Europe, and then can see the typical price of the fuel cell electric vehicles is around over like $6,000 US, $60,000 US. So it's roughly twice more expensive to the conventional internal combustion vehicles, or even the battery electric vehicles. But through the mass production, as you've seen, the price will drop very rapidly. So you can see the probably 10 years or even 30 years later, the price range of the fuel cell electric vehicle will be comparable to other conventional technologies. And then the key reduction of this price comes from the change of the price, or reduction of the price of the fuel cell systems dramatically by going to the mass production. Okay, thank you for your attention.